So now let's do a few problems from section 6.1. The first one asks us to find the margin of error given the values of C, sigma, and n. All right, this should be pretty straightforward because we know that if you want to find the margin of error, it's just the critical value of z, zc, times sigma over the square root of n. Okay, so we've already been given that n is 81, that sigma is 2.8, and we know that a C of 0.90, if we look over here, that's a 90% confidence level, would give us a critical Z of 1.645. So now just plug those in. 1.645 times 2.8 over the square root of 81, and we should get approximately 0.512. All right, for number 2 here, construct the confidence interval for the population mean mu, given these values. Okay, again, we're just going to set up an interval that's going to be starting at x bar minus e, the margin of error, and go up to x bar plus e, the margin of error. Okay, so let's figure out the various things. We have what x bar is, 6.9. We have sigma, we have n. So we're going to need to find first the margin of error, which again is the critical z value, times sigma over the square root of n. So we have all of that except for the critical value of z, but we know that for a 98%, that would mean, so that's not actually on one of our charts, so 98% would mean that there is 2% left in the tails, which means there's 1% in the left tail. Okay. So now if we look up the z-score associated with an area of 0.01, then we're going to find that our critical value is 2.33. So now if we go back over here and we find E as 2.33 times sigma was 0.3 over the square root of 40. That's going to give us about 0.11. So now we're going to build our interval. So we need x bar minus e and x bar plus e. So that would be x bar was 6.9 minus 0.11, which would give us 6.79, and x bar plus e would be 6.9 plus 0.11, which would give us 7.01, and that gives us our interval from 6.79 to 7.01. So let's move to problem 3 now. Now we're starting with the confidence interval, and we're going to go back and find the margin of error and the sample mean x bar. So this isn't too bad, because when we're given the confidence interval, if you think about it on a number line, we're being told that from 0.382 to 0.500 is our confidence interval, in the middle would be x bar, and the way we would have gotten the 0.5 is we would have added e to the right, and we would have subtracted e to the left to get the 0.382, meaning that basically the width of this interval is 2e. All right, so e would be just half of the length of this total confidence interval, so 0.500 minus 0.382, in other words, a half times 0.118, in other words, 0.059. So that's the margin of error E, 0.059. And then if we wanted the sample mean, well, we know we could start at the 0.382 left end of our confidence interval. If you added e to it, that should bring you to x bar. So if I do that, I get 0.441, and this is x bar. Realize that if I took x bar 0.441 and added another e to it, I'll get to 0.500, the right endpoint. Now problem 4 here. Find the minimum sample size needed to estimate mu for these given values. Okay, so that we saw that this basically is just a calculation of n based on z critical, sigma, and e. So if I just calculate the critical value of z times sigma over e, I should get value for n. So we saw previously that a c value of 0.98 gives us a critical value of 2.33. So n is just 2.33 times sigma has been given as 6.6. Divide that by e has been given as 1. Square that, and we should get approximately 236.5. But again, we're talking about sample size, so we're going to round that up to the next whole number, which is 237. Now for problem 5 here, what we're going to do is we're actually going to get two different confidence intervals, one at 90% confidence and one at 95% confidence, and see how they compare. So let's get the data out of the problem here. So it says a random sample of 45 home theater systems. So we already know n is 45, has a mean price, so x bar is 127. Assume the population standard deviation is 1790, so that would give us a sigma of 1790. So now, in each case, we're just going to do E is z critical times sigma over the square root of n. So now if you remember back from the chart there, a 90% confidence level gives a critical z value of 1.645. So we're going to do 1.645 times sigma is 17.90 over the square root of 45, And this is going to give us approximately 4.39. We're then going to just add. So this is going to be, the left endpoint is going to be x bar minus e, or in other words, 127.00 minus 4.39. And the right endpoint is going to be x bar plus e, which would be 127.00 plus 4.39, and that's going to give us 122.61 to 131.39. So there's our 90% confidence level interval. So if we do the same thing now for 95%, the only thing that's going to change here is that the critical z-value is now 1.96. So I'm quickly just going to go through the calculation of the margin of error here. So this is going to give a margin of error of 5.23. Again, I'm just going to take x bar and subtract 5.23, and I'm going to take x bar, which is 127.00, and add 5.23, and that's going to give me a 121.77 to 132.23. Okay, so then if we look, let's compare. Notice that the 90% confidence interval level went from about 122.6 to about 131.4, and the 95% confidence level is a bit wider, goes about from 121.7 or 121.8 to a 132.2-ish. So what could we say here? Well, it's actually C here. With 90% confidence, it can be said that the population mean price lies in the first interval. With 95% confidence, it can be said that the population mean price lies in the second interval. That's just our meaning of a confidence interval. The 95% confidence interval is wider than 90%. Now that makes sense, because if you're giving a greater level of confidence, then you need to widen the interval to have a higher probability that you are containing the mean in there.